In this video, we're going to learn about database constraints and how to apply them in a Django project. Now, a database constraint is a restriction or a limitation on the possible values that can go into a particular column or a combination of columns in a database table. And we're going to see some examples of constraints soon, including the following constraints. We're going to look at the primary key constraint in a database table. We're also going to look at check constraints, and we'll see unique constraints and not null constraints as well in this video. And most importantly, we're going to see how to apply these constraints to fields in our Django models so that you can programmatically add validation to your database layer using Django. So let's not constrain ourselves any further by listening to me, and let's dive in and look at the code. So let's start with a look at the restaurant model, which is the main model we've been working with in this series. Now, this model has a variety of fields, but I'm going to look at one field just now called capacity, and that is a positive small integer field. And the reason I'm going to look at that is just to demonstrate that we've actually already defined some constraints with Django, although we might not know about it. Now, certain Django model fields, such as the positive small integer field, they are going to create a constraint automatically on that column in the database. So what I'm going to do is open up our SQLite database browser, and let's go to the restaurant table now, and I'm going to go to the modify table statement, and we're going to have a look at what's defined here for these fields in the table. So if I scroll down, we have the capacity field, and this is an unsigned small integer type in SQLite. And if we look at this column here in the table, it's got the header of check, and you can see the constraint that's defined here for the positive small integer field. It's making sure that this field capacity is always greater than or equal to 0. So when you create this positive small integer field using Django, when you have a field like that on your model, behind the scenes in SQLite, a check constraint is created on that field, and that ensures that no values that are less than 0 can be added to that column in the table. And that's the whole idea of a constraint. We are limiting the values that can be put into a table column. And in the case of a check constraint, there's some conditional logic to determine whether that value can be accepted by the column. And if we look below here, we can see how the check constraint is created in the SQL code. So we have a create table statement for the restaurant, and I'm going to copy this into VS Code so that we can see it better. So the statement to create the restaurant table, we have a field called capacity in this create table statement, and you can see the type here of small int unsigned, and then you can see how we define the check constraint in SQL. We use the check keyword, and we're passing the condition to that. And it's a very simple condition. We're just checking if the capacity value is greater than or equal to 0. And that's the purpose of a check constraint, to limit the values that can go into a column based on some condition. Now, what other constraints can we create in our application? Let's go back to models.py, and we're going to define some other constraints in a second. But before that, let's go to this documentation here from IBM. This will document the types of constraints that you have in a database. Now let me make this bigger so we can read that better. Now, a constraint is a rule that's used for optimization purposes, and some of the constraints you see here are a not null constraint. That's a rule that will prevent null values from being entered into the column. We also have a unique constraint, and this is a rule that will forbid duplicate values in one or more columns in a table. We have a primary key constraint here as well, and that's a column or combination of columns that has the same properties as a unique constraint, and a primary key gives you a way to identify a row in a relational database. We also have foreign key constraints, and these are rules about values in one or more columns in one or more tables. So for example, if you want to link an entity in one table to an entity in another table, you will use a foreign key for that, and that's a type of constraint. We also have the check constraint that we just saw. Now, if we go to our database browser for SQLite, we can see some of these constraints here at the top. So I'm going to expand these out. So we have a not null constraint, and you can see most of the columns in the table are checked. That means that most of these columns will not permit null values. Now, if we look at the Django model, the way this works is that unless you define null equals true as a keyword argument to the model field, then null values are going to be disallowed. So by default, when Django creates a column, it's not going to allow null values unless you tell it to allow those. And we can see some of the other constraints. The primary key constraint in this case is defined on the ID column, and that's a typical example. We have an identifier for the row, and that can be a numerical ID or a UUID, and it's typically only going to be one column or maybe two columns that constitute the primary key in a table. And if it's a numerical primary key, you will often have an auto incrementing primary key, and that's what the AI stands for here, auto increment. And that means that when you have a new record going into the table, it's going to look at the value for the ID of the last record, and it's going to add 1 to that. That's a simple way to think of auto incrementing. And then we have unique constraints here, and I don't think there are any in this table, but a unique constraint can be defined, for example, on an email column. So it's impossible for 2 users to have the same email address. So you might want to impose a unique constraint there. We're going to see that later in the video. We have default values as well, and we just saw the check constraint earlier. Now before we start writing the code, I'll just show a very quick example of a unique constraint. If we go to the user table, you can see in the unique column here for the username field in Django's user model, we have this unique column ticked. So the username column has that unique constraint. And if we look at the SQL code here for the username, you can see that all we need to do in SQL is just pass unique when we're creating that column as part of the create table statement. So that's enough talking from me. Let's get writing some code now. If we go back to VS Code, what I'm going to do to start with is define an explicit check constraint using Django. So let's go to a page in the Django documentation, and I'll leave a link to this below the video. We have an object in Django called check constraint, and if we scroll down we can see how this is used in some code. We define the check constraint and we pass the conditional check as this keyword argument here, and you can pass any expression in the Django ORM. For example, you can do an OR statement between 2 queue objects, as you can see here. So we're going to look into this in a second. We're going to define a check constraint in our tables. And the table that I want to look at, or the model in Django that we're going to look at, is the rating model. Now remember from before, a restaurant can have many ratings, and a rating belongs to a restaurant. So we have a foreign key from the rating to its parent restaurant. And we also have a field here called rating, and that's another positive small integer field. And we've attached 2 validators to that, and we're specifying that the rating should be between 1 and 5. So we shouldn't allow values above 5 for the rating. Now we need to make a distinction here between a validator in a Django model field and a database constraint. Now validators, as we saw in an earlier video in this series, they're very useful for working with Django forms. And if we have a form that defines this rating field, and then the user enters a value that doesn't match what these validators expect, your form processing code can then raise a validation error and return the form to the user for them to fix that problem. Now one thing to note though is that these validators are not enforced at the database level. So even though we expect a value between 1 and 5, that is related to the forms. But if we try and create a rating model in a way that doesn't involve a form field, then these validators by default are not going to be applied. So in order to demonstrate that, I'm going to go to our 𝗰𝗃script.py, and I'm going to import the user model from Django for this example here. What we're going to do is we're going to fetch a restaurant and a user. So let's get the very first restaurant and user from the database. And then we're going to try and create a rating based on this restaurant and this user. So we're going to use the rating model. And in order to create a new example here, we can use rating.objects.create. And this rating is going to belong to the restaurant, and also it's going to belong to the user. So we're attaching the 2 foreign keys on the rating model here. We have a foreign key to the user and also to the restaurant. So let's add them here. And the other thing we need to add is the rating. So remember, we have a min value validator and a max value validator that is supposed to limit the values between 1 and 5. But as I said, that applies to the forms in Django. We can pass any rating here. So let's pass a number that's way outside of that boundary. And then once we've run the create statement, we're going to print the new rating out to the terminal. So let's go to the terminal now, and we run this script with python manage.py run script. That's a command from Django extensions. And you can see when we run that we get back the new rating, but that number, as I said, is way outside of that 1 to 5 range that we want for our ratings. So the code that we have in the model, the validators, they are not applied at the database level. If we go to the database now and we look at the rating table, I'm going to go to the bottom where we have the new record, and you can see that that has been added. So the rating column in this table is allowing a value that's way outside of our boundary. So how do we prevent this using Django? How do we add a check constraint to this column that will enforce this at the database level? We're going to use a check constraint, so let's go back to our models.py file, and in order to add a constraint, what we're going to do is define a meta class on our rating model, and we're going to define a field on that meta class called constraints, and this is going to be set to a Python list. And if we go back to the Django documentation, what we're going to use is the check constraint, and that's defined in the models package, which we've imported at the top. So let's define a models.check constraint and we're going to pass some values to this. Now we're going to give the constraint a name. So let me go to the bottom here, and we're going to pass a name of rating value valid. And the important argument to this is the check argument. That's going to define the conditional logic for determining whether a value is acceptable or not. Now the check should look at the rating field here, and it's going to check, is the rating greater than or equal to 1, and is it less than or equal to 5? So what we're going to do at the top is we're going to import the Q object from Django. So let me import that here from Django.models. We're importing the Q object, and we'll go back down to the check constraint here, and we're going to pass a Q object to this check constraint. And the first conditional check is to check the rating field and make sure that it's greater than or equal to 1. And we also need to pass a second one. And again, we're looking at the rating column here, and we're going to check that that's less than or equal to 5. So the logic of this check constraint using the Q object is to make sure that the rating is between 1 and 5 inclusive. And because we have two conditions passed to the Q object, they are going to be ANDed together. And that's what we want here, because we want to make sure that both of those are true. And there's a final argument I want to pass here, and that's the violation error message. So if we try and pass a value and create an object with a value that's outside of the boundary, what's going to be returned as the error message is this here, rating invalid, it must fall between 1 and 5. Now a check constraint is a database level change, so what we're going to have to do is run Django's migrations. So let's run python manage.py, and it's the make migrations command to start with. And you can see the migration message. We have created a constraint called rating value valid. Once we've done that, we can then run the migrate command, and that's going to try and add that to the database. Now you can see the problem that we have here at the bottom. When we try and create the constraint, we have an integrity error, and that's because there is a value in our rating table, and that's the one that we added a minute ago. And you can see that here with the value of 53,000. This value would fail the check constraint that we're defining on the column, and therefore the database is telling us that we cannot add that check constraint. So what I'm going to do is just remove this row from the database. We don't need it anymore. And just like that, the value is gone. So what we're going to do is go back to VS Code, and I'm going to try and run migrate again. And this time that works fine. So we've added a check constraint to the database. We can validate that by looking at the structure of our rating table. So let's go to modify table. And if you look at the SQL at the bottom here, you can see right at the bottom we have our check constraint. So that's going to enforce this check on the rating at the database level, and we can validate that by going back to the ORM script. So if we look at the code here, we're trying to create a rating, and that worked before when we had that high rating, but if we run the script now, hopefully we're going to see an integrity error, and we do get that now. We're no longer able to add that because our check constraint that we just defined is failing. So the check constraint allows us to add this logic at the database level to prevent these values being entered, and that can be important if your database has multiple ways of having data being entered, not just from Django forms. If we go back to models.py, we have the check constraint now, and that's defined in the meta class using the constraints field. And we can define multiple constraints in a single model class. So what I'm going to do is go to the restaurant model, which is at the top here, and we have a meta field already in this model. Now let's say we want to enforce some validation on the latitude and the longitude. So again, we would go to the meta class here, and we're going to add a key of constraints, and I'm going to paste this value in for each one of these fields. What we need for the latitude is we need to ensure the value is between -90 and 90. So what we're going to do is add a check constraint here, and we'll give it a name of valid latitude, and we're defining a Q object here that checks that the value is greater than or equal to -90 and less than or equal to 90. Now because we're defining constraints in a Python list, we can pass multiple constraints into this object here. So as well as latitude, we can define a constraint on the longitude, and that is exactly the same as the latitude, but the values are now -180 and 180. So let's save that, and we're going to run the make migrations command. That adds the two constraints to our model here, and then we can run migrate, and that's going to add them to the database. And this means that there's no way for a value that's outside of these ranges to be added to either one of those fields in the table. We can see that again if we go back to the database browser. Let's go to the restaurant table now. I'm going to go to modify table, and let's expand this out. Now the check constraint doesn't seem to be showing up in the check column here, but you can see it at the bottom. We have the constraint valid longitude, and then the check constraint is defined here, and similarly for the latitude. So this is now working. What we're going to do in this video now is move on to unique constraints, and we're going to see how to define those in Django. Now, as I said earlier, a unique constraint specifies that the values of a column or a combination of columns must be unique across the database table. And under the hood, what this is going to do is create a database index over that column or that combination of columns. And an index will allow very fast and efficient retrieval of data for those fields. Now, we're going to see more on indexes in a later video, but let's now go back to Django. Now, there are two main ways to define a unique constraint on a field on your model. So let's look at the first of these techniques. It's very simple to do. We have a restaurant model here, and that has a field called name. Now, I'm going to make this a little bit nicer to read by separating these arguments into new lines. Let's say we wanted a restaurant name to be unique. So no two restaurants across this database can have the same name. I'm not sure if that's a good approach for a restaurant name, but let's go with it for this example. The very simple way to add a unique constraint is just to pass unique equals true as a parameter to the car field. So if I was to save that and run make migrations at the bottom, that's going to add the migration file. We can then run migrate, and hopefully this is going to work. And then if we go back to our restaurant table here, let me go back to that table now. If we click modify table and expand this out, if you look at the fields on the left hand side, the name field for the restaurant is at the bottom, and the unique flag is now checked, which means that restaurant names must be unique. And you can see that in the code for the create table statement. We have the restaurant name, which is of type varchar, and it has the unique constraint. So let's demonstrate how this works by going back to the 𝗰𝗃script.py file. I'm going to clear the code that we had before, and I'm going to pull a restaurant that already exists out into this variable called restaurant. And then we're going to run restaurant.objects.create. And what we're going to pass as the name is the same name as the restaurant that we've already pulled from the database. And that should not work because we now have a unique constraint on our restaurant model on the name field. Now I'm going to pass some other arguments into this just to fill out the function, and then we can import time zone at the top. So let's import that now, and we're going to run the script to see what output we get. So let me clear the terminal, and we're going to run 𝗰𝗃script.py. And again, we're getting the integrity error, and this time it says the unique constraint has failed on the core restaurant.name field. So the problem here again was that we're trying to create a new restaurant in the database, but we're setting the name to the name of an existing restaurant that we pull out on line 7 above here. We cannot have two restaurants with the same name because that column in the database now has a unique constraint. Now this was the very simple way of creating a unique constraint in Django. We just pass unique equals true into the car field, but we can create more complex unique constraints using Django's unique constraint object, and this object is quite similar to the check constraint object that we've already seen. So why might you want to use a unique constraint object rather than just passing unique equals true? Now for a start, if you use the unique constraint object, you can apply a unique constraint over multiple fields in the table. Now as an example of this, a restaurant name might not need to be unique because restaurants in different places in the world may have the same name. That's going to be very common actually. But you might want to have a unique constraint over two fields here, the restaurant name and its website. Now no two restaurants are going to have the same name and the same website. So you could create the unique constraint over the name and the website field. So that's multiple fields here. Of course, a website should be unique in general, so maybe that's not necessary, but just to demonstrate an example of that. And another benefit of using the unique constraint is that you can actually apply an expression. Now to demonstrate what this would do and why this might be good, if we go back to the ORM script, what if we just uppercase the existing name of the restaurant? So I'm going to add that in here, and at the bottom we're going to run the ORM script again. This time we're not going to get back the integrity error, and that's because the name is not technically exactly the same, and that's because we've uppercased the existing name, so it's going to be slightly different in the database just based on the casing. Now that might not be optimal, so what we're going to do is we're going to remove unique equals true from the car field, and we're going to create a unique constraint in the meta classes constraints field. So we already have two check constraints. I'm going to go below here, and we're going to define a models.unique constraint. Now you can see the first argument here, it's the expression for defining this unique constraint, and we can just pass in a field name. But what we can also do is we can use an expression. Now, in order to prevent the example that we saw here where we just changed the casing and we're allowed to enter a new value for the name that just has a different case, what we're going to do is we can use the lower function in Django, and we've already imported that because we're using it in the ordering, and it's the name field that we want to lowercase here as part of this unique constraint expression. And as with the check constraint, we can also define a name for our unique constraint, and we're going to pass this as the name because it's being applied to the name field. So again, we've added the unique constraint, and that is a database level change. So we need to go back to the terminal and we need to run the make migrations command, and we're going to see that when we run migrate here, this is not going to work because we added that uppercase name, and that's going to cause the unique constraint to fail. And you can see that integrity error at the bottom. In order to remedy this, I'm going to go back to the database and let's look at the restaurant data here. I'm going to go to the very last one, and you can see it's got that uppercase name. Let's delete that from the database, and then we're going to try and add that constraint again. And just like that, it's gone again. Let's go back to the terminal and we're going to clear this out and rerun migrate. And once that's done, what we're going to do is clear the terminal, go back to the 𝗤𝗵𝗽𝗶𝗹. Now this worked before. We were able to add the restaurant with the uppercase name, but now we've added an expression to the unique constraint. So let's try running the ORM script now, and hopefully this is going to fail, and you can see we now get the integrity error. The unique constraint has failed, and that's the name that we gave to our new unique constraint. So the benefit of using the unique constraint object like this in Django is that we can apply an expression, for example, to lowercase or uppercase a string, and we can also enforce uniqueness among multiple fields by using this unique constraint object. So let's now finish the video with one last example of unique constraint over multiple fields. Now we can do this with the rating model that we have in the application. So let's say this was a real application and we had users that were going in and giving ratings to restaurants. Now you might want to add a unique constraint here that enforces the rule that a user cannot apply a rating more than once to a restaurant. Therefore, the combination of user and restaurant should be unique in this rating table. So let's enforce that by going to the meta class, and we're going to add another object here to the constraints list, and that's going to be a models.unique constraint. And this time we're going to pass the fields in as a list, and we don't need to use an expression here. We're just going to use the user field, and it's the restaurant field. And let's give the unique constraint a name of user restaurant unique. So this unique constraint is going to look at the raw values for the user and the restaurant, and these are foreign keys to those respective models. And if a user tries to enter a rating for a restaurant that they've already rated, this should now fail. So again, we need to run the make migrations command in order to apply this database level change. That's going to create the migration file, but again, we're going to get an error when we run migrate here, and I'm going to show you why that is. Let's go back to the rating table. We're going to browse the data in that table. Now this series, we've only got one user in this series, and every one of these users has an ID of 1 in the rating table. So there are multiple instances of a user with rating 1 applying a rating to a restaurant more than once. So here's an example. User 1 has given a rating to restaurant 13, and they've done that multiple times in the application. There's another example there. And the unique constraint that we're trying to add prevents this from happening. A user cannot have multiple rows in the table that are giving a rating to the same restaurant. And that's why this unique constraint that we've added here is not going to work. But that does make sense in a production application. By adding that constraint, you're going to prevent the user from being able to give multiple ratings to a restaurant. And this might apply to any kind of area. For example, if you're familiar with the site Glassdoor, you might want to prevent a former employee who's particularly disgruntled from adding multiple reviews for a company on that site. So you can add a unique constraint between the user and, in that case, the company, to ensure that a user will only be able to add one review for that company, and that can apply to anything, for example, a product you've bought on Amazon, or any number of examples. And with that, that's all for this video. Thank you for watching. If you've enjoyed this video, please give it a thumbs up on YouTube and subscribe to the channel if you've not already done so. And if you're enjoying this content, consider buying a coffee for the channel. There's a link in the description. Thanks again. We'll see you in the next video.